Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and in this video I am going to explain you geometric distribution, a kind of discrete distribution, that is, you can say that variant of binomial distribution with some extra properties. So without further delay, let's get started. So let a sequence of Bernoulli trials, and you know that what is the Bernoulli trial, in which there are two kind of results, success or failure. So each with constant probability. So here sequence of Bernoulli trials and each with constant probability P of success and Q 1 minus P of failure, as I have explained you. And basically in Bernoulli distribution, Bernoulli trials, not distribution, trials are independent and we continue performing them until the first success occurs. See that this is the condition where geometric distribution comes in picture. So performing them until the first success occurs, and let x be the number of failures, means random variable preceding the first success, both one if you combine. So x denotes the number of failures preceding the first success. Now then x can be take values, discrete values it may take 0, 1, 2, 3 and so on. And the probability of failures before first success, see that probability of failures. So 0 failure preceding the first success. So the whole probability means P, probability of success, that is. Now probability of one failure preceding the first success, that means Q into P. And here there was no failures, so there was not Q. Now failures will increase. So see that Q square P, that means 2 failures preceding the first success, and so on. Now in general, the probability of x failures preceding the first success, that would be P, random variable x, value x, and Q raise x P, where x is from 0, 1, 2, 3 and so on. So you can see that the respective probabilities P, that means without failures, QP, first failure, thereafter success, form a geometric progression with common ratio Q here. That is a geometric progression with common ratio Q. And this is the one of the region that its name is geometric distribution. So this probability distribution is known as geometric distribution because in respective probabilities form a geometric progression. That's why its name is geometric distribution. Now let us define what is a geometric distribution. That means not a, but what is a geometric distribution? So a random variable x is said to follow a geometric distribution if it assumes non-negative integer. That means it must not be -1, -2 or -5, whatever. And its probability mass function is given as Q raise x P, where x varies from 0, 1, 2. If it is negative, if x is negative, so value would be 0. And sum of all probabilities, that would be 1, because see that here P into this one So that would be equal to, yes, I am showing you here, that would be equal to 1 upon 1 minus p q, not p. So that would be 1 upon p, and already 1 upon p we have, so that would be 1. So sum of all probabilities, that is 1, and this is the necessary condition for a distribution, probability distribution, probability mass function, probability density function or probability mass function. Now let us take an example. An unbiased die is cast until 6 appears. So just find the probability that it must be cast more than 5 times. So let us solve it. So probability of success, because there are 6 faces, so getting 6, that is 1 upon 6. And what would be the Q? 5 upon 6. Probability of failure. Probability of success, probability of failure. Now let number x is the number of failures before the success. So that is a random variable. Then by geometric distribution, q raise x p. So here die is cast more than 5 times. So p x greater than 5. So here you will find out sum of these probability when x is equal to 5, x is equal to 6, x is equal to 7, because condition is x is greater than or equal to 5. So 5 is included. So see that here, if we substitute, we will get this value, and that is basically infinite geometric series sum. So here r is equal to 5 upon 6. So basically r cube. So here if you plug the value here q, and here already we know. So if you simplify, so 5 upon 6 raise 5, and then the probability that die must be cast more than 5 times is 5 upon 6 raise 5 here. So this was the example. Now let us calculate mean of a geometric distribution. So you know that the mean of a distribution, you will multiply x multiplied by probability mass function. So let us calculate it here. Just reduce one power, and just x would be here, and see that here what happened here, x has come here and 0, see that it was from 0, so we have just started from 1. So what will happen if we take 1, so that will become 0, and if we take 2, so that will become 1. So the same series is here, same series. Now we can write in this form. So here we will just use a trick. So see that here if we differentiate q raise x, so that would be x q raise x minus 1. So the same thing we have written here, and thereafter we can write in this way. So see that this property we are going to use, sum of derivatives is equal to derivatives of the sum, and here we can write in this way also, derivative is outside, now because sum of this term from 1 to infinity, that would be q upon 1 minus q. So we can write dq here, d over dq, q 1 minus q. And see that now we can differentiate it using quotient rule. Quotient rule. So here we are differentiating this term, that is very easy maths from the calculus, and you must know the formula. So if you differentiate it, this is the numerator and that is the denominator. So here denominator into differentiation of numerator. Here numerator into differentiation of denominator upon square of denominator. So this formula I am using here. Now if you simplify it, you will get p q into 1 upon 1 minus q square, and here this is 1 minus q square, that is 1 upon p square, and finally expected value of random variable x is q upon p, or mean of x. Now let us understand variance of geometric distribution. So you can understand this one we have already calculated, expected value of random variable x. Just we need to calculate this part. So here probability mass function q raised x p. Thereafter, if you want to calculate expected value of random variable x square, so you have to multiply it with x square with probability mass function, and we will calculate. So we can also write, we can take p out from the summation, and thereafter here I have already explained, we know that the expected value of x here p upon q upon p. Thereafter we need a similar trick using differentiation, the same trick we used in to calculate expected value of x. So here q raised x q upon 1 minus q. So if we differentiate both sides with respect to q, so we will get this expression 1 upon 1 minus q square, and thereafter again if we differentiate to 2 upon 1 minus q raised q, and this trick here we will use in binomial distribution. We have also used, that means it is equal to x square, because here x square x will get cancelled by minus x, so that I can calculate here x square minus x plus x, that is equal to x square. So this trick and differentiation will be used to find out the variance of random variable x. So here you can express this, and thereafter if you multiply both sides by q, so and simplify, so you will get this expression q into 2 upon 1 minus q raised 3. Thereafter, and this one already we know that. So again x summation x square q raised x minus 1, that would be equal to 2 q upon 1 minus q, and this one 1 upon 1 minus q square. Thereafter if you multiply p, so that will be expected value of x square. So if you simplify and if you keep or put 1 minus q is equal to p, so we will get expected value of x square is equal to q 2 minus q upon p square. Thereafter plug the value and finally we will get expected value of x square equal to q bracket 2 minus q upon p square, and expected value of x we already know, and x square this part, and variance we know that variance of x that would be equal to expected value of x square minus square of expected value. So we will plug the values, and here if you plug the values, so finally we will get variance of x q upon p square. And what was the expected value of x? It was q upon p. Now variance, let us see the relationship. So variance is greater than mean. Usually what happens, mean is always means greater than variance, but in case of geometric distribution, variance is greater than mean. Let us see example 2. The mean and variance of a geometric distribution are 4 and 3 respectively. Mean is 4 and variance is 3. So is it valid? So let P be the probability of success in each trial. So then mean would be q upon p, so that would be 4, and variance q upon p square, that would be 3, and 1 upon p, that would be 3 upon p, and that means p is equal to 4 upon 3, which is impossible because probability can never exceed unity. So that means that statements are wrong. So hope you understood. For more resources, you can visit website www.postnetwork.co, YouTube channel, and handle is @ PostNetwork Academy, Facebook page, also page name is PostNetwork Academy, and also GitHub, LinkedIn and GitHub you can visit. So hope you understood. Thanks for watching the video, and hope you will support and subscribe the channel.